Hey everybody, this is Larry. This is day 6 of the Leetcode Day Challenge. It is May 5th here in New York, so happy Cinco de Mayo to everybody. Let's take a look at today's poem, and we're having another linked list poem. Nah. I don't know, I just don't care that much about it, but let's take a look at what it's saying. 24087, we moved notes from a linked list. Hope everyone's having a good weekend, by the way. I'm okay. It's really rainy here in New York, and I just went for a quick 2-mile jog, but... I'm a little bit tired, but I'm always tired, it seems like, because I'm jogging every day. You're given a head of a linked list. We move every node that has a greater value anywhere to the right side of it. Right side of what? To the what? Oh, that's a very. This is a very poor phrase of it. We don't. The linked list doesn't always. It's not the next node is not always the right side. You could draw it however you like. But okay, so you want to remove a node in which the next node is smaller, right? Okay, I mean, yeah, it should be pretty straightforward in theory, but it's still very annoying to do. But the first thing we're gonna do, I always just write a sentinel. I call it new head. I don't know why, right? Head, right? And then now we can do current is equal new head, and then we just go through the thing, right? So while what do we want to do? So dot next is going to be the node that we're looking to maybe remove. So that means that dot next is the actual node that we care about, right? Well, that we care about existing. So we want something like this, but of course that also we have to do a double check to make sure that one node exists. But I think because zero node does not. There will not be an input where there is 0 nodes or none. So I think this should be fine, but my math is usually pretty bad, so I don't know. You let me know, right? So while this is not none, if current.next is greater than current.next, then what do? Then we just remove it, right? So current.next is equal to current.next, and we're done, and then we continue. Otherwise, we move the pointer, and I think that should be good, and then we return new head.next. Hopefully this is right. Oh, whoops, dot value, of course. Did I mess this up? We moved 5, we removed the 2. Did I misunderstand this? What? Oh, anywhere to the right of it, not just that's a way. Okay, I misunderstood this form. And also, like I said, the left, right is kind of weird for linked list. So okay, so I did not read the problem correctly. So let me think about this for a second. I mean, I think if we allow linear time, linear space being the key part, then this is pretty straightforward. But I'm trying to think of a way to do it better. Can I do this in constant space? I mean, yeah, sorry. This definitely is not the right code because I just misread it. Because basically, a greater value to the right of it. I didn't even get the signs right. I don't know. It is very weird. Okay. Let me well, I mean, I think we can definitely do something, but it's going to be linear space anyway. I mean, we can do something very clever, but it doesn't bias that much, so it's kind of a little bit awkward, right? And the way that we can do it is just by I mean, I think the other way to think about this problem, right, is to actually think about the index that we're trying to keep. And the thing that we're trying to keep is going to be using essentially like a mono stack, I want to say, right? You just keep nodes on a stack, and then And when you get a bigger thing, you query it up, right? So basically, you have something like this, right? And then while current, current is equal to new head. While current dot next is not none, then standard stuff. But then here, then now, we want to see if we want to keep current. Yeah, right. I guess in that case, actually, now that I think about it, I mean, I have an explicit stack, but I guess you could actually use the actual linked list as the stack, which is maybe interesting. But because then now what you want to say is that we keep the current node if because basically you want to go 5 and then you go 2 and then you have 13 and then you pop the 2 and then the 5, right? But the thing is that you have to be able to pop, so I think you still need to stack, because if you have a doubly linked list, then you can do this in one pass. But here, I think you still need to do it this way, right? So then now here, we want to say while length of stack is greater than 0 and stack the top of the stack, we're going to keep the nodes dot value is less than current dot next dot value, then stack we pop, and then at the end we put stack dot append current dot next, right? And then now I'm just going to return none for now, but so I could print it. Maybe that's a little bit awkward because it's going to print out too much stuff because it prints the entire thing, right? So x dot value for x in stack, something like that. Don't tell me generator. Okay, fine. Tell me generator. Right, so now we have 13.8 and 1.1.1. So this is exactly what we want. And yeah, but then now we just have to kind of put the new things together. So new head.next is equal to stack the top of the stack. And I assume that, I mean, there should always be at least one element in the stack. Stack, I guess that's that. And then, yeah, for I in range from 1 to length of the stack, then, yeah, stack of I minus 1 dot next is equal to stack sub I. And that should be it. The top of the stack dot next is equal to none, and then we just return new head dot next. But yeah, let's give it a submit. Hopefully this is good and it looks good. What did I do last time? Why did it take 3-4 seconds? But yeah, this basically is what people would call a mono stack. But as you can see, we don't care about. We just care that it's a stack. We don't care that it's a monotonic stack. We just kind of have this property of keeping the things that are possibly, we're just keeping things, right? Because basically, if you ask yourself the reverse of this problem, you go to 5 and you go, okay, do we keep this? Yeah, let's keep it for now. You go to 2, I'm looking at this here. You can't see my mouse, but look at the 2 and you go, do you keep this? Yeah, we keep it for now. And then you look at the 13 and you go, do we keep this? Yes, but then now you go back and go, okay, do we keep the 2? No. And then do we keep the 5? No. So you remove it. And then now, and that's basically the idea. And then in this way, you get a mono stack. What did I do last time? Why is it so slow? Did I do an n square? Oh, that is actually pretty clever. But why is this so slow though? I don't know. But yeah, but basically I just did it in reverse. But this is the same idea. Alright, this is linear time, linear space due to the stack. Can I do better than linear space? I'm gonna take a look. Recursion, linear space, reverse twice. I mean, I did that in the other thing. I guess. I mean, I don't know that that's. I guess okay, fine. I guess that's true. I mean, here we don't reverse. I mean, we did reverse it, but reverse it by looking at it in a way. Is this a contest form? I think yeah. I mean, the reason why I did it that way is because it was a contest solution. So I'm not going to try to get it, with like this, to be honest. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.